so I wanted to make a short presentation about home servers. Anybody here running home servers by themselves? Hey, come on, quite a few. All right.
Not home server, home servers.
Home servers, wow, okay, nice. I actually got into that kind of activity like 2-3 years ago because I had like too many Ps at home, Raspberry Pis, and just like, okay, I have to do something with them. So I decided, okay, I'm gonna make them run like 24/7 and just like see what I can do with them. Through this exercise, I learned a lot about how to set up, how to run application, how to do the reverse proxy, NDX, Apache, and these kind of things that you're probably very familiar with. It was a lot of fun, but like soon I realized that the Raspberry Pi, I was using Raspberry Pi 1 B+, something like that. Yeah. Which is pretty limited power-wise, like memory-wise. You have like half a gig of RAM. It's like one processor, one CPU, one core, basically. So you hit the limits pretty soon when you want to do something a little bit more ambitious. Like I was even trying like WordPress, MediaWiki, just like was getting very, very slow for these kind of things. So I said, all right, I need to, if I want to do more of this, I need to step up and find something that's more appropriate hardware-wise. And I was looking for a number of alternatives for work quite well. And as you know, if you're familiar with the space of our ARM boards, there's a lot of them available. There's and they all have like the kind of same stupid name like banana pea, orange pea, orange pine, like different fruits, more or less. It's really hard actually to understand how different they are from each other because they share pretty much a lot of very similar specifications. They have a bit of differences here and there, and they are especially different in terms of software support, I would say. Like you would see, like this kind of Chinese copycats tend to have decent hardware, pretty cheap, but actually very poor distribution hardware support. So therefore, you're stuck on very old kernel, like 3 point something of Linux. So like, and this, all these kind of drivers, they stay in that kind of space, and you can't move to the the mainline kernels anytime soon. There are some efforts to bring a more standard distribution, such like community-driven ARM-BN. I don't know if you've heard about that, which is a kind of distribution that's made to support as many of those boards as possible. So that should make it easier, at least to run servers and this kind of thing on modern, modern kernels. So that's that. But one of the main issues with all this kind of board is that actually you're low on memory most of the time. It's really hard to find more than 1 gigabyte of RAM. Maybe you can find 2 maximum. Higher than that for this kind of format, form factor is really hard to find most of the time. You're also limited by the ports you have. Most of the time it's USB 2. Sometimes you got 1 or 2 USB 3 ports, but then you don't have eSATA, or some have eSATA but they don't have USB 3. And you also limited in network connectivity with Ethernet ports, which only have like usually 100 megabits. Where you want to have gigabits kind of connection if you want to make fast connections with your network. Yeah, go ahead.
Why do this?
Why do I do this?
What's the
I will talk about the why at the end.
Okay.
So let me come just about the how first, and then I will come with the why. Yeah. Yeah. So I was looking at the Orange Pi. It was decent, but very poor, software support, unfortunately. I think this was my main option for a while until like end of last year. As Odroid is a Korean company that makes pretty very powerful ARM SoC boards that have very decent specifications. They also have USB 3. They have eMMC memories for typical stuff you find on mobile phone, very fast memories access. They also have gigabit connection. So it's pretty much what you want. Unfortunately, they were out of stock when I wanted to order one, so I was like, okay, so too bad I have to wait several months because there was no ETA as to when it would be available anyway. So while I was waiting for that,
question.
Yeah.
So isn't there all this support because of different chipsets and things like that? You have problems with the software and getting drivers to do it, whereas Raspberry Pi just popular. So you,
Even the Raspberry Pi is not standard like mainline kernel. It's actually they have their own drivers, like proprietary drivers, and they are constantly patching with the new kernel that they're releasing. So actually, it's the best supported proprietary device out there, but it's actually not mainline. There's actually some effort to bring the Raspberry Pi to be mainline kernel. So some folks are developing drivers to actually support through the mainline the Raspberry Pi hardware, but it's taking a long time. I think they're not even supporting the first yet, even they're halfway there, I think. So yeah, most of the ARM stuff is very unfriendly for drivers, unfortunately. So and you will find actually when you look at the Armbient distribution page, all of those hardware has bugs somewhere, like this boot bug, like you cannot boot from the memory there. You have to put the SD card reader first. Like it's a mess. Like I mean, you can do it, I guess. Like you should have to go to a lot of pain just to get to server running basically. So it's kind of frustrating somehow. And I was looking for other alternatives, and also. I was considering, like cost-wise, Raspberry Pi, you don't think about it because it's very cheap, like $35. It's like, it's like a couple of Starbucks, right? But when you get to these kind of different, more advanced ARM boards, it gets more and more expensive actually, and you cross easily like $100 when you add a fan and actually a capable power supply, because this one, for example, needs already like stable power supply. If you cannot just use your normal like phone power supply for that. At least it's not recommended apparently. And plus you have to buy the memory that goes with it. That's another $40. So you basically cross the $100 easily. So it's not really like cheap anymore, I would say, like compared to the Pi. So then you can start comparing like what about the Intel solution out there? If you want something very powerful and has more like official support, I would say. And there's the Intel NUC, NUC. You have also like the Asus Tinkerboard, which is also Intel-based, I think. But those get a lot more expensive, like in $300, $400 and more. And that's not even adding the cost of storage and stuff like that. So I went the other way and looked at what's available in used materials, right? And actually, you can find very cheap rack servers. And so this is not the same form factor at all. This is like huge. This is the size of half this table here, and this is like 8 kg. It's like steel casing. It's really heavy. So it's not something you're gonna replace the space you are using for your Pi, right? But hardware-wise, it's actually very capable, and it's actually very cheap because a lot of data centers are actually replacing them on a regular basis, like every 4 or 5 years. And those basically I bought this one like probably 4 or 5 years old. A Dell Air 210-2. That's basically being replaced now in most data centers with more modern hardware, and basically throwing them away for like nothing. You can get this kind of hardware for like each month like 10,000 plus yen, which is about the same price as what I was mentioning before for like this kind of thing here. Of course, yeah.
Don't they have normally use a SAS SCSI disk and things like that?
Yeah, they have SATA ports and everything, so it's actually typical standard hardware. And the good thing is that they come usually with storage, with memory. So I mean, of course, you can replace them if you don't want to use something that's too old. But actually, you already get everything in hand. You can just plug in it; it will work and boot directly. The cool thing is that actually you have lots of ports too. Sorry, yeah, go ahead.
So for this 18 month, how much storage space do you get on that?
So storage, you mean the space or the memory? Storage, like 500 gigabytes. And that's actually two RAID disks, so two hard drive of 500. But don't get me wrong, they're not new, right? They're old drives, but they were still working fine. Yeah. Yeah. Another question there behind. That's a question here. No. Okay. You get a lot of ports. You can.
Is this 1 unit high or 2 units high?
It's 1 unit.
Isn't this very noisy?
Actually, not. I actually chose that one particularly because it was one of the less noisy servers around. And this one is pretty silent. If you were comparing with the previous, the HARD 210-1, it was very noisy. But actually, they made it a lot more silent in the second iteration. That's why actually it's well known among people who actually buy this kind of used stuff because it's actually you can actually put it in your room and you don't hear it too much. I'm not saying it's silent as in like, you know, a Raspberry Pi, right? But like, it doesn't make too much noise, and you can be next to me, we don't hear it. Yeah, it's right. Some kind of Wi-Fi. Depends your Wi-Fi, I guess. but I was actually sleeping in the next room to where the server was this for like several months, so it was not bothering us for sleeping anything. So it's just an example. And it's very thin, so like, you can imagine like actually it's just a few centimeters high, so you can really fit under actually a table or something. You know. It's really easy. So it has many ports. It has gigabit internet, as I mentioned. Has VGA ports, whatever you want. It has USB ports, has like 3 or 4, I guess. Even internal USB port, like 2 more inside. And you open it from the top, like you slide basically the cover, and you can access the hardware like that. And this is what I mentioned for the question you had. Actually, you have 2 hard drives that's located on each side there. One under there, one under there. This is the DVD drive, and this is a red controller. This is your CPU unit there, where you have actually the whole cooling system. It's two fans that are cooling the system, as well as the passive cooling is whole like a system to actually also evacuate the heat by the design of the cooling system, and the PSU there. And so it's actually pretty easy to operate and to open. So it's like typical like standard PC architecture. You just connect the SATA, the SATA connector and stuff like that. So there's nothing really particular if you're used to building your own PC, for example. 8 kg, so it's pretty heavy, but you don't touch it every day, so like it's fine. You just put it there and leave it down. It's a 1-socket 1-unit server, so 1 unit as mentioned before. A single PSU, so like in case the PSU fails, of course your server would go down, but like same for your Raspberry Pi, right? And once it gets interesting, I didn't know about this kind of stuff until I actually had one. It's like it has an intrusion system alert, where actually you will detect if somebody is tampering with the cover. So it has actually a memory inside, if sensor that detects like if somebody is opening your cover when you're not there. Of course, not for me, but like for data centers, I guess like they want to know like when is the last time somebody actually operated it. So you can actually access this and automate like monitoring of this kind of memory, and then you can get an alert if somebody is opening your server. It's actually pretty cool. My model had a Xeon CPU. It's a low voltage one because I didn't want something that consumes too much power, right? Because Raspberry Pi would be like 5 watts or something, like almost nothing. I wanted something that was not like 100 watts because it's probably going to cost a lot in electricity every month. So I went for something, I think this one consumed like 20, 30 watts in idle, and average I would say like 40, 50 watts, like basically a lamp if you leave it on the whole time, which is reasonable. It came with 8 GB of RAM, and that RAM is not just regular type of RAM you get, it's actually ECC memory, so like error correcting. So it would not fail, basically it would prevent data loss through the RAM, or data corruption through the RAM. So actually it prevents like another source of failure in your server. And you don't get this kind of RAM in typical, hardware you buy for like a Raspberry Pi or ARM boards like that. So it's kind of, higher end of RAM hardware. And actually it's pretty expensive by itself. You probably pay as much as each month for this kind of memory. So actually you kind of get it for free in a way. As I mentioned, you get a red controller, so you can put 2 drives and they will basically replicate each other during the operation to ensure like even if one drive fails, you would still have your server running. Again, as a security you don't have with your typical ARM board. You also PCI, eSATA, and USB 2 port, not 3, but yeah, at least you got the eSATA ports if you want to really fast transfers. This is what I'm running currently. I don't know if you can see the bottom parts, but so IRC server, SingSing is basically a replacement of Dropbox. Also mini DLNAs for streaming media, music and movies, through your home network. Litchi is a photo gallery, WordPress of course, a MediaWiki instance just for me. And also, because I'm working on this kind of stuff like an R server, a Jupyter Lab server, and an Nextcloud as well. Nextcloud is pretty much like a kind of a storage, kind of do everything kind of system. It has also a kind of web calendar, CalDAV and CalDAV system, so you can exchange and synchronize your contacts in your calendar. It's very practical if you want to get out of like Google Calendar, this kind of solution. Actually, you can do the same thing with a self-hosted solution. And so the stuff, the reason why I put the stuff in orange and red there is like the stuff that I could not physically run physically on Raspberry Pi before, or at least without great level of pain. The one in red was basically impossible to run because it was not enough memory. Orange was barely running but not usable. So now with this kind of hardware, I can actually run all of this together at the same time. It's very, very smooth. It barely goes beyond like the 5-10% CPU usage. So except when I'm doing compilation. So it's very decent kind of hardware in terms of power. So now to your questions to why one would do that, right? So it's not for cost reason, right? Because if you look at VPS solution or this kind of remote servers that you can rent or or purchase in co-location, for example, probably it's more expensive to have this at home because the cost has been increasing so much in the past few years. However, I would say it's probably yes and no, because if you look at this kind of hardware, this kind of memory, this kind of storage, the cost of renting this is probably around like dozens of dollars per month. So if you were to compare with the cost of electricity of running this and the purchase, initial purchase, maybe it's about the same potentially, but I don't know. I didn't do the actual calculation, but I'm guessing it's not anyway a huge money saver or anything like that. What was interesting for me is just the learning part of it. It's like I was interested in running a server and understanding how it works and how you set up from scratch. And the more I got into it with the Raspberry Pi, the more I wanted to do more with it, and to actually be able to do most of what I wanted to do myself. So that's pretty much like skill building kind of thing. Of course, and I'm using also the services I'm hosting. So it's at the same time as kind of DIY solution. Also, I'm also using it daily for everything that I work with. I'm moving away from Gmail almost completely now because I'm hosting most of my solutions and also except search, you can host that on your own hardware. But most of the solutions that involve private data are trying to move to that kind of solution as much as possible. And the other reason why I think it's worth doing, if you're interested in that kind of thing, is I would say decentralization of your network. The fact that the internet was not made to be centralized into 2 or 3 companies, right? It's actually made to be working by different nodes located in different places, right? So it's just still possible to do that actually, and there's a lot of services out there, the solution that outsource, open source out there that you can use to enable you to drive those services and replace most of what you're doing actually. So I think it's nice actually. We have this kind of possibility out there still 2018, and especially for the services that involve private data. I really want to go into this kind of space where I'm in control. I know where it's stored. I know how it's stored, and I'm in control basically of what I'm doing with it, instead of trusting a third party, which you have no idea what's the deal with them. I think that's my main motivation around it, and I'm actually also it's useful because I think probably most of you have used server or are using server for your daily occupations, right? But when you're actually building, setting up servers from scratch, you learn a lot about actually many other things. So you really understand that your understanding was really shallow in the beginning, and you actually there's a lot of things involved in the distribution, in monitoring, resolving the kind of failure modes that the server has. That actually are very interesting in themselves, and makes you more knowledgeable in a way as to how all these kind of things work behind the scene. So I think it's worthwhile if that's something that you're always interested to see how things are working. By general curiosity, I would say.
So, for instance, can you rent your service?
Oh yeah, you can develop and run your own services there. So there's lots of web developers in this room. So you can also use that kind of thing for experimenting your own applications before putting them into production servers, for example. Because you can run Ruby, Django, all this kind of stuff on this kind of server. And it's basically typical hardware you would run them on anyway, so it's pretty much like the speed that you would expect from a running application. Yeah.
Question, how do you manage redundancies if your server crashed?
Regular backups.
And also how you probably lose emails because you can't reach your mail server because it's bad.
So I don't host my. So the thing about emails that it's almost impossible to host your email locally at this time and age. Because like all the ISP are blocking different ports to actually send email. So because they consider everything coming from a local IP is actually spam. So like it's just impossible. What you can do is receive email is not an issue. So like if somebody addresses you an email, if you can actually have a mail server that receives emails, no issue. You can get them and you will be able to open them, no problem. Sending is the issue. So for sending, what you do is actually you would rent. You could pay for SMTP server, this remote, and you send it to it through a secure connection, and then that way you can still have actually the local server with the sending capability.
Couldn't you use VPN also? Or do they block them also?
To connect to a different machine, yeah, but
No, you're sending out to mail.
yeah, you could. Yeah, you could do that. Yeah, you could connect through VPN, but like that kind of defeats the purpose of having your own server. I would say because then you have to trust the VPN server.
You know what I was trying to say? Sorry.
Continue.
Yeah, I was just trying to say is that because I used to set up my own email server, getting all these things. Suddenly you run out of space or the system crashed or whatever, then you lose email because they can't reach you. They get bounced back. And friends saying that you got your wrong email or whatever. So you got that kind of issues
for this
your own thing.
So if you worry about this kind of thing, you can use like forwarder system. So like basically and you can use an intermediate email that will be forwarding to a different server basically, where you would collect the same email. So that increases redundancy. But it's not that difficult. And here you have like RAID controllers. So like basically you can ensure that there is no like the hard drive failure is not going to stop your server unless it crashes at the same time. It almost never happens. At least there you're confident like they will keep running almost 24/7 unless something really bad happened to your physical server.
Is your server like public facing?
Sorry?
Because I saw you've got like you're running like local media stuff and that kind of thing as well. But and running WordPress, is your WordPress like public facing?
It's public facing, yeah.
So what are you doing? Like a couple of questions on that. So are you running just a local home ISP? Do they have any issues with running servers? Sometimes. No, nothing at all?
Nothing at all. Actually, not with the service I had so far.
Okay, and so what about security then? Because if you've opened it up, then you're sort of opening up.
Yeah, I mean, of course, like there's like firewall that blocks all the ports I don't use. Also, the router has also like security as well. Yeah. So it's not like it's completely open to anybody to trick with it. There's also like typical stuff like fail to ban, where you will like basically block any IP that tries too many times to connect to your server. It's probably good enough. Like, and I've been running the Pi for years, and was kind of like the second system. It's never been hacked from the outside world, so I don't think that's a major issue. In terms of running from home. Yeah.
Depends.